Number 3 says 25 pi over 18, find the reference angle. So I'm going to give myself a horizontal and a vertical axis to work off of. So 25 pi over 18 means that I'm going to have everything in terms of pi over 18. So that means on top of my graph on this top half, I'm going to have 18 segments. And I don't want to draw all those. Also means I have 18 segments or 18 sectors on the bottom as well. So 25 pi over 18. What I know is that this is 18 pi over 18. And this is 0 or 36 pi over 18. 0 or 2 pi. And then I could even find the difference there. If this is 18 pi, I could go up here and say, well, this is 9 pi over 18. Same thing as pi over 2. This one down here would be 3 pi over 2 or 27 pi over 18. So if the entire thing is in pi over 18, then one quadrant is 9 pi over 18. So 9 plus 9 plus 9 gives me 27. That's useful because I'm trying to go 25 pi over 18. So that's going to go somewhere into quadrant 3. And I don't care exactly where. So 25 pi over 18 is my angle theta. My reference angle then is always drawn to the horizontal axis. That's a right angle. Call our reference angle theta prime. And so I need to figure out how did I go from 25 pi over 18 back to 18 pi over 18. So 25 minus 18 gives me 7. So my theta prime is exactly 7 pi over 18 radians away from the horizontal axis. Again, I had 25 pi over 18. I used my blue radian measures 9, 18, 27, and 36 to figure out the quadrantal angles instead of pi over 2, pi, 3 pi over 2, and 2 pi. That gave me a reference of where my 25 should be. It should be in quadrant 3, so I drew that closer to the 27 than to the 18. And then to go from 18 to 25, 18 up to 25 is 7, so there's 7 pi over 18 as your reference angle. So for example, if you took the cosine of 25 pi over 18 in your calculator and got a decimal, you should get the exact same thing if you take the cosine of 7 pi over 18, except it would be negative because it's to the left.